Hello and welcome to an Innova Systems webinar. My name's Sam Bromley and I'm going to show you how to create animations with SolidWorks. So animations in SolidWorks are created with what we refer to as a motion study. A motion study allows a graphical simulation of movement within an assembly model. With the correct use of lighting, cameras and mates, SolidWorks animation creates a realistic representation of mechanical movement within an assembly. With this showcase, I'm going to show you how to set up and create a simulation of movement within SolidWorks. We're going to look at two assemblies. First off, we're going to create a very basic animation using the assembly that I've got in front of me here. And secondly, we're going to look at a more complex assembly and animation. So first off, we're going to talk about ensuring that we've got the correct type of mechanical movement. So if we have a look at this assembly, it's currently undefined. So these components are free to move around their degrees of freedom. Now what we would need to try and do here is reduce the amount of degrees of freedom that these components have to simulate the type of movement we would expect from this assembly. So what I'm going to do is, and we should all know how to do this, I'm going to start applying some mates to the assembly, reducing degrees of freedom and resulting in unexpected mechanical movement. So that's the only mates I'm going to apply there. And what we should have is the red and the green component sliding within each other. Now that's exactly what we want there. That's the type of mechanical movement we may expect from this assembly. And that's what I've set up here. And secondly, we're going to look at creating an animation to show that mechanical movement. So to start an animation, in the bottom left hand corner we've got what we call the motion study tab, and to access a motion study and start an animation we need to ensure we tick that, and what we're displayed with is what we call the motion manager. So this is the motion manager. Now we need to ensure that the drop down of the motion manager is specified to animation. That's the type of study that we're going to create. And I'm just going to give you a brief overview of the interface of what we can see in regards to the motion manager. So on the left hand side we have a very familiar tree here. These are the components which we are allowed to animate. You may not always see everything in that tree, but this is what we've got access to. Secondly, we've got key points for each one of these components, and these essentially indicate the position, the motion, if any properties that are specified within the current parameters of this key change. We've got a few options here in the toolbar. We're not going to look at all of these. One quite important one we are just going to change right now is one of the options within the motion study properties is the frames per second. Now 8 is too low. With 8 frames per second we're going to have jittery movement within our assembly. Now what I tend to use is around about 24 frames per second. This is similar to the type of FPS that we'd get on a TV screen. So we shouldn't see much jittery movement at all. So 24 or above, you shouldn't see too much of that jittery movement. So we're going to accept that. And what we've got here is what we call the timeline. And at the top, along the top here, with the second counting across to the right hand side, we've got what we call the time bar. So what I'm going to do is I'm going to start creating some motion here. Now the process I'm going to take with this particular assembly is what we call position-based animation. I'm going to move components to a new position, ensuring I've got my time bar in the correct position along my timeline, and then I'm going to move a component. So first off, from 0 to 4 seconds, I would like this component to be in this position. Now you'll notice that I get an automatic change bar here. This is what we call this coloured bar, a change bar. And that is an indication of a change of a property from the first keyframe to the second keyframe. And that's exactly what we've got. The green colour indicates a change in position we've got motion here. There's lots of different other coloured change bars that we'll experience, and I've pointed a few out in the more complex assembly, but this particular one indicates a change of motion. That's what green colour means. Now you'll notice I didn't have to tick any other buttons here apart from drag the component to a new position where my timeline was positioned in a different position along my time bar. Reason being is I've got an option here called auto key. An auto key allows me to automatically create new key positions, whereas I could go about manually creating and adding a new key. So what we're going to do secondly is we're going to complete this animation. We're going to move along the timeline to 6 seconds, and we're then going to move the green component to a new position. What we get now is a yellow time bar with a hatch. That indicates that the animation itself needs recalculating. So an animation is very similar to a simulation. It is simulating motion, so there is some calculation required. So what we're going to do is, I'm just going to show you if I move the timeline, you can now see that the position of the timeline will show us the current position of those components in regards to our animation. You will note here there's quite a bit of jittery movement. This again points towards a recalculation required. So we're going to calculate here. And we're certainly getting some motion there. Not quite what we expect to get though. The green component is moving with the red component from 0 to 6 seconds. What we'd like to have is that green component moves only between 4 and 6 seconds along our time bar. So all I'm going to do here is I'm going to drag the very start position of that component to 4 seconds. I'm going to recalculate, and we're now getting a much more desirable motion here. The green component moves from 4 seconds to 6 seconds. That's exactly what we wanted. Now the key points themselves can be deleted simply by right-clicking and deleting. This will remove the change in which the component has made between that time period. We can always undo. Now, another thing I'm going to point out here is the interpolation mode of that motion that we have. So currently, we've got a linear motion. It starts and it stops. It doesn't accelerate or decelerate. It just moves from point A to point B. Now what we can do is decide to ease in that motion. So if we ease in that motion with this particular key point, if we recalculate again, as you can see we need a recalculation because we've become hatched again. It might be a little bit tricky to see when we play it back, but what we should have is the acceleration of that green component, which we do get. Okay, so that's a very basic understanding of how we can go about manually creating motion, and that's what we call position-based animation process. Now secondly, we're going to look at a much more complex animation. So we have an assembly, which I'm going to open up. This assembly here. I'm going to go to its motion study. What it's indicating here is that there's been some changes in the assembly. Would like to update the affected keys? The answer is yes. And what I've got here is a partially set up assembly and animation. So we've got much more going on here. We've got a time bar which runs from 0 to roughly 40 seconds. And a few things I'm going to point out in regards to the existing animation within here. Just going to make the motion manager just a little bit bigger. I'm going to scroll down in the tree and find a bit of information here. You can see there's some components that are already currently set to animate and move. And we've got a green change bar here, which indicates, as we've discussed before, motion. And then secondly, we've got sort of a pink and purple colour. Now that indicates a change of appearance within components. So that could be the change in colour. It could be the change in regards to if they're hidden or shown, or even their transparency. But I want to point this out now because in a moment we're going to have a look at maybe when that occurs and exactly what happens in regards to the animation. So I'll bring that back down so we can then see our two windows. And what we've got here is we've split the viewport to two horizontal panes. We've got a left and a right. And that's a really useful thing to specify here. And to do that, we go to Window, Viewport, and To View Vertical, splitting the two views down the middle. Now, the reason why we do that is because on the right hand side we can then freely move around the assembly, making changes to components, whereas the left hand shows our current camera. So this is actually showing how much we've done in regards to animation already. Now, a few things I'm going to point out here. You'll note that when I move my time bar, the camera not only moves on the left hand side, but it also graphically moves on the right hand screen as well, showing the current position of that camera. Now, as you can see, it's moving at a very fluid motion around the assembly itself. So why is that? Now, what we've done here is we've set up, much like they would do it in a film studio, we've set up a track. So this sketch here is currently utilised as a track for the camera, and it will move along that spline upon a period of time within the animation. We'll have a look at that in a second, because we're going to add a new track to our assembly and get this camera here to follow the track that we create. So let's deal with that now. So we're going to go to around about 14 seconds here. And as you can see currently, at 14 seconds, our camera view for our animation goes from camera 1 to camera 2. As we move through the assembly itself, we can see we have the change of appearance of those components. And this is what we were discussing earlier. So the pink change bar that you could see indicates the change of appearance, and that change of appearance is the transparency of particular components. So as you can see here, they become more and more transparent. So we can see more and more light through those components. The reason why this is set up is because what I want to do here is have my camera move through that chamber. So let's set that up very similar to camera 1. So first off, the camera is in the correct position here. It's exactly where we want it. We want it pointing at that chamber. But we want it to move along a spline. Now, let's show this sketch and highlight it as well. What we've got here is a sketch which moves through the assembly. The camera is already fixed to this spline, and we're going to get that camera to move along the spline. So from about 14 to 30 seconds, we're going to have that movement following along. So let's set that up. So what we're going to do is, we're happy with its current position. We're then going to move our timeline to 30 seconds. And we're going to edit the properties of the camera. So at 30 seconds, we don't want that camera in this position. We in fact want it at the very end of the spline. And just a note here, this is how that camera is tracking along that spline. It's got position by selection selected, and that spline is its position. So we'll accept that, and just keep an eye on this area here. When we accept that, we can see we get another change bar which indicates a change in position of that camera. So now if we pan back through, we'll see that camera itself moves along that spline through the transparent objects to this position, and so forth. So that's our camera setup. Now, what we're looking at here is an assembly which has got fully defined mechanical movement. So let's hide these cameras because they're getting in the way. We'll also hide that sketch. Now, this is where we show again the importance of ensuring we've got the correct mates set up and also the correct mechanical movement. So if I attempt to rotate this flywheel, what we get is all those components moving also. Now I could go about going about the same approach we did with the first assembly, which is to go about using the position-based animation process. So I could manually move that wheel at different positions to create the mechanical movement. But what we are going to do instead is drive this animation with a motor. So with this motor, we can drive mechanical movement whilst controlling its parameters at key points. So that's what we're going to do secondly. So we're going to go to motor, which is this button here. We're going to specify the component direction, so the motor will be driving what component in what direction, like so. We're going to go for constant speed at 100 RPM. Now what we're going to do is we're going to ensure we're doing that at the very start of the assembly. So select the component again, 100 RPM. And then we're going to move all the way to the end of the assembly and say that the parameters of the motor have changed. So edit the feature. We're going to say it's gone from 100 to 0. So it's slowing down its movement, its rotationary movement that it's creating. We're going to accept that. Again, little warning here saying that we need to update the affected keys. Answer is yes. And we're going to change the interpolation mode so that eventually the motor will slow down. So it's going to ease into that RPM of 0, which means it will slow down as it gets towards the end of those 40 seconds. Now you can see we've got a calculation required here. Now we are going to do that. We're not going to do the whole lot because this is quite a complex assembly. We've got a lot of mates here that need to be solved as that motor turns. We've now got a motor driving the mechanical movement. We've also got a lot of cameras which are dynamically moving around our assembly. So the calculation time for this assembly takes quite a while. We're not going to sit through all of that. We're going to let it chug through a very small amount, and then I'm going to stop that process. I'm just going to play back to you the very small amount that it calculates, just to show you that it is then actually driving the motion of this assembly now using a motor. So I've hit stop there, so that should stop in a second calculating. And I'll show you on the animation screen. If we now play the animation itself, we've now got that motor driving the assembly's motion, which is great. That's exactly what we want. Now what I do have is an assembly here which is fully complete. It's the same assembly. And we've got that motion and that calculation complete. So we're going to hit play, and as we can see, the camera goes through the flywheel. It moves around the assembly itself and should eventually pan upwards, like so. At 14 seconds, it's going to snap to the second camera. It's going to move through those transparent components that we've specified. Then follow along that path towards the end of the assembly, and finally at 30 seconds to 40 seconds we've got an isometric view of the component slowing down. So the interpolation mode was to ease into that 0 RPM, and there we have it. It stops at 40 seconds. So a few things I'm going to point out before we move on to show you the final video is that we can save out animations. So more often than not, you're going to want to save out as an AVI. But what you can do is save out as a series of images as well. So we've got a choice of bitmap or TGA, and a size of the image as well that we can alter. Now again, this frames per second here actually relates directly to the video that's going to be created, not the animation that was initially created. So again, you're going to want to set something like 24 frames per second here to get something more realistic and something that doesn't have any jittery motion. Now we can decide to use a SolidWorks screen, which is what is utilised for the final video that I'm going to show you. We could also ask to be rendered with photo view. Now, photo view will render every single frame. So if you've got a 40-second long animation at 24 frames per second, you can imagine that's going to be quite a few individual slides and frames for that to render. And depending on the aspect ratio and image size that you specify, and also the quality of photo view, that can take a very long time to complete. Now if we were to save, we get one final option here, which is the compressor. I've downloaded something called TechSmith Screen Capture Codec. Now that's a codec recommended by SolidWorks themselves. It gives a nice smooth, complete video, so certainly worth utilising there. You can also save out with full frames, so entirely uncompressed. It would be a very large file size, and you would have to do some post-editing, some editing afterwards in some video editing software. Now we're not going to save that. What I'm finally going to show you is the end result of the video, rendered, I'm afraid, only in the SolidWorks screen, not in photo view. It would certainly take a very long time to do that. As you can see, it dynamically moves around the animation, the assembly again. Should snap to camera 2, moves through the transparent objects. I'll just let this play through. And that should slow to a halt, about 40 seconds. And there we go. So I hope we've looked at some useful things in regards to animation. And we can't show everything, obviously, in animation. There's certainly lots to look at there. So I hope you've seen something useful. If you've got any questions at all, please do get in contact. There's our email at the bottom there, and also our number. We will be hosting some future webinars. So if you ever feel like you want to watch any more of these, please go to the website, register for the future webinars, and get in contact also. So I hope this has been useful to you, and thanks for watching.